Hi everyone, my name is Jasper Kay, and today I'll be explaining one of the most useful ideas in electrical circuits, the current divider rule. This rule helps us predict how current splits between branches in parallel circuits, a fundamental concept in circuit analysis. The amount of current that flows through a branch is determined by a branch's resistance. A higher resistance concedes less current flow, while a lower resistance allows more current to pass through. So the current divides inversely to resistance, meaning the easier path, the more current it carries. The formula that describes this relationship is selected current equals the total current multiplied by the total resistance over the resistance of that selected branch. Written out, it looks like the following on the right, with a special case included. This formula means that the current through any branch equals the total current multiplied by the ratio of total resistance to that branch's resistance. If you look at a circuit, you can see that the branch with the smaller resistance ends up carrying more current. That's the essence of the current divider rule. For example, if one branch is 4 ohms and the other is 6 ohms and the total current is 10 amps, using the formula we get the results of I1 equals 6 amps and I2 equals 4 amps, both combining to 10 amps. The smaller resistor gets the larger share of current, just like how a larger pipe allows more water to flow. It's a simple but powerful relationship. Within a parallel circuit, both branches share the same voltage across them. According to Ohm's law, V equals IR. Since voltage is constant, the current must vary inversely with resistance. So, when resistance increases, current decreases, and that's why the current divider rule works. Imagine electricity flowing like cars on a road. When cars reach a fork, more take the wide, smooth highway, the low resistance path, while fewer take the narrow, rough road, the high resistance path. The total flow divides, but the easier path always carries more traffic, just like current in a circuit. Engineers use current dividers everywhere to design smarter, safer, and more efficient circuits. In audio electronics, for example, they control how much signal goes to each speaker, like a balance knob that splits current between the left and right channels. They also use in sensor and power distribution circuits to ensure each branch receives the correct current. It's simple in theory, but critical in practice. To summarize, the current divider rule shows us how current splits between parallel branches. It's based on Ohm's law and the inverse relationship between current and resistance. Thank you for watching.